Okay, I will introduce the second question's solution. And in these questions, it asks if it's possible to collect the definitions or property of fast stochastic process. The first one is WSS. The definition of WSS is like if xt expected value is a constant, and its correlation depends only tau, namely T1 minus T2 only, then we could conclude that this is a stochastic process is WSS. And the property of wide sense stationary is that it only involves the first and the second order moment. So we couldn't conclude that WSS is definitely be a SSS because SS involves the higher order moment. The second is independent increment process. The definition of this is if for any non-overlapping intervals, the probability is equal. It satisfies this whole equation, and the probability is like the independent increments implies the uncorrelated increments. The third one is Markov process. If a stochastic process is a Markov process, then we can conclude the past has no influence on the statistic of the future if the present is known. And the property of it of course, from the definition we can conclude that the statistic property of the Markov process is determined by if one knows his second order distribution function. The fourth is SSS. We said that a real stochastic process ST is stationary in strict sense, namely SSS, if its statistics is not affected by any shift on the time axis. The property of this process is that the two processes xt and xt plus simple have the same statistics for any epsilon. The last one is the white noise. White noise, the definition is like if R T1 and T2 equal to this equation, then we can conclude this noise is a white noise, and the property of the white noise light is it is a process light. Its values at different times are uncorrelated. Okay, this is solutions of the questions 2.